Yes, hello, you're welcome to another topic, and we are going to look at testing the difference between two means. In the previous lectures we've been looking at concepts of hypothesis testing, but using Z, T, and chi-square tests, where we've been comparing the sample mean or variance or proportion to a specific population mean, variance, or proportion. And these have been used to determine whether the null hypothesis should be rejected or not. But then there are cases where we need to compare true sample means, not comparing a sample mean to a population mean, but then our interest or our researchers' interest could be to compare two sample means using different experiment and control groups. So for example, if you're interested in comparing two brands of fertilizers, if you want to see which one is better than the other or whether there is a difference in their mean efficiency. So we follow the basic steps of hypothesis testing. So we are going to first look at a scenario where where we are testing the difference between two means for a large sample. So suppose we wish to determine whether there is a difference in the average age of agriculture students who enroll in a technical institute and those who enroll in a university. The difference in the average age of agriculture students who enroll in a technical institute and those who enroll in a university. So in this case, we are interested in the average age of all beginning students, but comparing the means of the two groups, the group that enrolls in an institute and then that enrolls in a university. So the research question would be for that case is whether the mean of age of agriculture students who enroll in a technical institute differs from the mean age of agriculture students who enroll at the university. So therefore, our H0 or null hypothesis will be that there is no difference in the means. In other words, the mean of students who enroll at the technical institute is equal to the mean of students who enroll at the university. And the alternative will be that there is a difference in the means. So the mean of students who enroll in an institute is different or not equal to the mean of students who enroll in a university. So that becomes our claim or alternative hypothesis. So there are different assumptions when testing the difference between two means. So these two samples must be independent of the other. For example, we have to look at the previous example. Students applying in an institute should not in any way affect students who apply in a university, and then the population from which the samples were obtained must be normally distributed, and the standard deviations should be known, and the sample size should be greater than that. Remember, we are looking at a scenario where the sample is large, or n is greater or equal to 30, and then the variance of the difference of the means should be equal to the sum of the individual variances. That if you get the variance of the first sample mean, and subtract it, we subtract the variance of the second sample mean from it, the sum should be equal to the sum of the individual variances, and that is what this means. So where variance of the first sample mean is equal to variance over the sample size, and then the variance of the second sample mean is variance over sample size of that particular sample. So therefore, since standard deviation is the square root of the variance, and this is our variance, but standard this is equal to this, the standard deviation will be the square root of this, because standard deviation is the square root of variance. So the formula for the Z test when comparing two means, remember when n is greater or equal to 30, we use the Z test. So from our test value, from our Z value, the standard formula, our test value or Z value will be the observed value minus the expected value over standard error. And therefore, when n is greater or equal to 30, when both samples are greater than 30, we use the above formula where x1 minus x2 represents the observed sample mean, and then the difference between the two expected means gives us the expected value, and then the denominator is the standard error. So, and that's which is represents the standard deviation. We've seen this in the above slide. So we follow the same steps when testing for the difference between two means. We state the hypothesis and identify the claim, find the critical values, compare the test value or compute the test value, then make a decision, summarize your results. So we are going to follow an example that is going to guide us, get meaning from all the above. So the question says that a survey found that the average rent of a hostel in Mukono is $84.42 per month, and the hostel rent in Makerere is $80.61 per month, and the standard deviations were $5.62 and $4.83 respectively. At an alpha of 0.05, can it be concluded that there is a significant difference in the rates? Is there a significant difference in the rates? So assume that the data were collected from 50 samples from each region, so meaning our N1 is 50 and our N2 is 50, which qualifies to have a Z test because both samples are greater than 30. So the solution, we state the hypothesis and identify the claim. And remember here we are comparing means. So our null hypothesis will be that the mean of the first population is equal to the mean of the second population, and therefore the alternative will be that there is a difference in the means, or the means are not the same. So meaning we are looking at a two-tail. So step 2, to find the critical values. So since we have alpha of 0.05, we can get our Z value or Z alpha over 2 value, the critical value, from our F table at the bottom. So we are going to go to our T table at the bottom. So we are going to look for it is a two-tail, so we look for 0.05. So the critical value is 1.960. So you all remember how we come to why we use this. So that will be our critical value of values. So since it is a two-tail, we have a not equal sign. It is not pointed to one direction. So we have both positive and negative 1.96. So these are our critical values, and therefore the shaded areas are our critical regions. So from there, from getting the critical values, we now compute the test value. We have our formula as this. We have the sample mean for Makerere and the sample mean for Mukono. So therefore we just substitute. Then the difference in the means is always 0, because that is what we are looking at, and then we have the various standard deviations. So like I mentioned, if the question has a standard deviation, you don't have to square it here. But then if it has variance, you don't have to square, but if it has standard deviation, then we square. So then that will give us 7.4. So now we compare the test value and the critical value. We'll check whether the test value lies in the critical region. So the next step will be to make a decision. So we are basing on that to make a decision. So does it lie in the critical region or in either of the critical regions? So this is our critical region, the tail. So since 7.5 lies in the critical region or the shaded area, or it is greater than the critical value, then we conclude that there is enough evidence to support the claim that the means are not equal, or we reject the null hypothesis. Remember, we reject the null hypothesis when our test value lies in the critical region, or when the test value is greater than the critical value. So we reject the null hypothesis, and the null hypothesis was saying that the hostels, the mean rent of hostels is the same. So therefore we take the alternative, which says that they are not equal, hence a significant difference in the hostel rents. So like we've looked at testing a difference between means of large samples, we can still get the confidence interval between two means of a large sample. So here, when we are hypothesizing a difference, if the confidence interval contains a zero, or if we get a confidence interval as a zero, then the null hypothesis should not be rejected. But then if it is a zero, if it is not a zero, then we should always reject the null hypothesis. So this is the formula. All confidence interval formulae are not very different. So this is the sample mean difference, that our z. Remember, this was supposed to be standard deviation, but now for this case, the standard deviation is this. So therefore, it is the mean, the difference in the population mean will be less or equal to this. So for this case, this becomes our standard error. So in the question, we are always given this, we are given everything. So you just substitute in the formula. And when you get a zero, then you do not reject the null hypothesis. But then when you get a zero, you do not reject the null hypothesis. But when you don't get a zero, you reject the null hypothesis and take on the claim. So now we are going to look at testing a difference between two means for small independent samples. Remember, we've been using the Z test when both ends, when each n is greater or equal to 30, but when it is less than 30, or when the standard deviation of the population is not known, then we use a t-test to test the difference between the means and the variances, when the variances are assumed to be unequal. So here we first test whether the variances, the first step always is to test whether the variances are equal or not, and therefore t-test has two procedures. So the first procedure is testing for equality of variances, and then when they are equal, we use this formula to get the test value, and then when they are not equal, we use the first formula to get the value of the test value. So where the degrees of freedom are equal to the smaller one of n1 minus 1 or n2 minus 2. Remember, we are comparing two samples, so whatever is smaller is what we consider as our degree of freedom. But when we are looking at a scenario where variances are equal, our degrees of freedom will be n1 plus n2 minus 2. So in summary, to use the t-test, we first use the f-test to determine whether the variances are equal, and then we use the appropriate test value. Remember, when the variances are equal, we use the first formula to get the test value, and then when they are not equal, we use the second formula to get the test value. So all these are now familiar to you. These are sample means, population means, variances, or standard deviations. So there are two processes, each with the 5 steps that we've been listing. So an example here, that the average size of a farm in Nakasongola district is 191 acres, and the average size of a farm in Kiruhura district is 199 acres. Assume that data was obtained from two samples with standard deviations of 38 and 12 acres respectively, and sample sizes of 8 and 10 respectively. Can it be concluded that at alpha is equal to 0.05, the average size of the farms in both districts is different? Assume that the population was normally distributed. So now our interest, we should always look at n. We see that both n's are less than 30, so therefore we use the t test. But then to get the appropriate t formula to use, we first test whether the variances are the same. And the formula for variance, so therefore our first process, we first use the F test to determine whether, so for variances we always use a table, the F table, or what we call the F test. So whether the variances are equal. So the null hypothesis will be that the variances are equal, and then the alternative will be that the variances are not equal. So step 1 in process 1, we state the hypothesis and identify the claim. So the hypothesis is that the variances are equal, that is the null, and then the alternative, the variances are not the same. Then we find the critical value. So the critical value of the F test is found in the F distribution table. So I'm going to attach all tables so that when a time reaches and you need to use any of the tables, you just access. I'm going to upload a copy of each. So an F table looks like this. This is our F table. So it has degrees of freedom of the denominator and then degrees of freedom of the numerator. But then the smaller one is always the numerator and the bigger one is the denominator. So we compute, we find the critical value from the table. So since, remember, this is a two-tail. So since we have an alpha of 0.05, we are going to use alpha over 2 because we are using a two-tail, it is a two-tailed scenario. So therefore we are going to choose a table, an F table of alpha is equal to 0.025. And then since the degrees of freedom are 7 and 8, remember our samples, one was 8, one was 10. So therefore there will be 7 and 9. So the critical value will be, so our F table, so we look for 7 and then 9. So this is an F table of alpha is equal to 0.025, like you can see up here. So you look for 7 and 9 degrees of freedom. Seven and 9 degrees of freedom. Is it 4.2? I think, which is a 4.2. So that is our critical value, which is a 4.2. So now we compute the test value. And in our next lecture, we shall see how this F formula comes about. So the test value for variance, we divide the variance, the bigger variance with the smaller variance. So the variances we are given, but they gave us standard deviations. So the variance, you can get the variances and then divide. Then we compare the test value with the critical value. So then we make a decision. So our test value is 4.2. And the test value is 10.3. So does 10.3 lie in the critical region? Yes. so it is greater than the critical value. So therefore, we reject the null hypothesis. So therefore, it can be assumed that the variances are not equal. So this is only guides us on which T formula to use. So since the variances are not equal, the first formula will be used to test for equality of the means. So now we start on our second process. We set our hypothesis where H1, H naught, or the null will be that the means are the same, and then the alternative will be that the means are different. Then we find the critical values. Since it is a two-tailed, the variances are unequal, and the degrees of freedom are the small of n minus 1 or n2 minus 1. So in this case, the degrees of freedom. So the smaller n was 8. So therefore, I take a degrees of freedom of 7. So from the T distribution table, we can get our critical value, which is the Z alpha value. So we look at alpha is equal to 0.05 and 7 degrees of freedom. So we go to our T table. So it is a two-tailed, so 0.05 and 7 degrees of freedom, so which is 2.365. But since it is a two-tailed, we shall take two values, so that will be positive or negative. So our test value is positive or negative 2.365. So this is now our critical value, which marks our critical region. So we now compute the test value. And since the variances are unequal, we use our first formula, which was this. We have all the figures for this, so we substitute and get a value. So what we get, we now compare it to the critical value that we've got. Does it lie in the critical region? Is it smaller or greater or smaller in a reducing manner? So that guides our decision. So since it is greater than negative 2.365, you see this is negative 5 is smaller than negative 10. So negative 0.5 is smaller than negative 2. So therefore it does not lie in the critical region. So therefore we do not reject the null hypothesis. So therefore, there is no enough evidence to support the claim that the average size of the farms is different. However much it was indicated in the scenario that they are different, but there is no enough evidence or there is no statistical difference. So that's it with testing the difference between two means. We started with testing the difference when the samples are greater or equal to 30, and then confidence intervals, and then when the when the samples are less than 30. So there we use a t-test, but then a t-test in this case has two processes where we first compare variances, and once the variances are unequal, we use the appropriate T formula to test for difference between the means. Thank you so much. Stay safe.